For our project, we're talking about laws of conservation. We will be using examples that relate to potential energy and kinetic energy, also known as PE and KE. In our video, our examples will include skating back and forth on a skateboard, watching the weight of a baseball hang by a string, and the calculations of speed, the speed of a pitch, and the joules of a building.
Energy is the ability to do work. Work is force times the distance. So we measure work and energy both in joules. There is a law of the conservation of energy. That law states that energy can neither be created nor destroyed. Since energy can neither be created nor destroyed, it can be converted. The two types of energy that we have are potential energy, energy due to position, and kinetic energy, energy due to motion. There are equations for both. Potential energy is m times g times h. M equals mass, g equals gravitational acceleration, and h equals height. Kinetic energy is half mv squared. M equals mass, v equals velocity of object squared.
The best way to look at how energy is converted from potential energy to kinetic energy is a pendulum. A pendulum is simply a weight attached to a string. If I hold a pendulum at one side and don't let it go, it has a certain amount of potential energy. When I let it go, the pendulum will swing back and forth. The energy is converted from potential energy to kinetic energy and then back to potential energy. This happens over and over and over again. When the ball is sitting at the top, it has all potential energy. When it's at the bottom, it's converted all that energy into energy of motion. So when it's in between, we would say it has a combination of potential and kinetic energy, and it's just converted. The pendulum will eventually stop swinging because of energy will lose in friction, heat, and sound as it moves. Eventually, it'll come to a stop.
When I am at the top of the ramp, all the potential energy is stored. The potential energy is my mass times the gravity of Earth times the height of the ramp. Halfway going down the ramp, the potential energy is then combined with the kinetic energy. When I hit the bottom of the ramp, all the potential energy is transferred to kinetic energy. So at the top, I have all the potential energy. Then when I am on the ground, it is kinetic energy and back and forth. Eventually, I will come to a stop due to friction and wind making me lose potential energy. Now, if I were to add more force by pedaling, then I could keep the cycle going and I would keep going back and forth on the ramp.
For kinetic energy, let's use baseball as an example. Let's say I pitch the ball at 20 miles per hour. Let's figure out how much kinetic energy would be in the throw. The mass of the baseball is 0.145 kilograms. We use the equation half mv squared, where m is 0.145 kilograms and v is 9 meters per second. You square the velocity, get half of the mass, then multiply. Then you get 5.9 joules as your answer. Let's do an example of potential energy. Let's say I climb to the top of a 10-story building. First of all, we have to know my mass, which is 78 kilograms. Acceleration due to gravity, which is 9.81 meters per second squared. And the height of the building, which is 32 meters. And then you have to multiply all together and get 24,485.76 joules, which is what I have at the top of the building.
And answer.
We won't see your sweet little face for 10 more years.
Jules. Oh.
The end